every second, every day, 24/7, nonstop, that sensor is making those judgments and improving its capability at every location across the world where we're deployed. We push those data sets and that learning to all the other sensors. So it just gets better and better at discerning drones versus birds versus other things it sees in the airspace.
You're listening to the Drone Radio Show podcast, the show about drones and the people who use them for business, fun, and research. Hosted by Randy Goers.
Hello, everyone. This is Randy Goers, and welcome to the Drone Radio Show podcast, episode 294. Is it possible to stop a rogue drone in its tracks? Today's guest gives us some insights. Timothy Bean is CEO of Fortem Technologies, a world leader in AI-enabled airspace security and safety. Most notably, the company excels in real-time intrusion detection. Through an advanced end-to-end system of distributed radar, AI at the edge, deep sensor integration, and autonomous drone capture, Fortem monitors and defends the world's venues, infrastructures, cities, and regions. The same system is accelerating the safety of the world's airspace for urban air mobility. Tim has more than 25 years of global executive experience successfully building businesses and technology startups in Silicon Valley. He currently oversees the strategy for Fortem Technologies and handles everything from product creation through sales to customer support. Before founding Fortem Technologies in 2016, Tim provided strategic oversight for all programs and services with global reseller partners in Japan and throughout the world. He has a vast array of knowledge in sales and engineering, with specific expertise in cyber defense and mission-critical infrastructure applications. In this edition of the Drone Radio Show, Tim talks about Fortem Technologies and its suite of products and services designed to make the sky safer from rogue drones. He also discusses the current challenges in delivering such services and the outlook for the future. But before we hear from Tim, I want to thank those of you who are supporting my funding campaign. Whether it's $1, $100, or much more, you can help defray the cost of production and keep the podcast going and growing. Go to droneradioshow.com/donate. And by the way, if you have an idea for a great show and want to share your experience, please contact me at randy@droneradioshow.com. So let's find out how we can stop rogue drones with Timothy Bean of Fortem Technologies. Let's pick up the interview where I asked him to introduce himself.
Hi, Randy. Good to be with you today. My name's Tim Bean. I'm the CEO of Fortem Technologies. We lead a company that detects and defeats dangerous drones when they enter places where they shouldn't. We also create corridors so drones will stay where they should stay. So it's a very exciting business in this new world of this automated economy and this new system, and it's great to be with you today.
Yeah, thanks, Tim. So let's talk about the company and how it stops rogue drones. So how does it do that? What products or services do you produce?
Yeah, thanks for the question. We produce a very disruptive new technology using 70-year-old radar technology. We basically have taken radar and put it into these tiny sensors that you can distribute maybe a few hundred around a stadium or thousands throughout a city. And so what this small radar does is it lights up the airspace straight into the sky. And what we're able to do with software now is create these volumetric exclusion zones, these 3D zones in space that once you have these software-defined spaces, we call this our SkyDome software, you can trigger rules engine. So if a drone enters a geofence where a drone should not be, and you can have hundreds of these geofences configured throughout a city or a venue or across a campus, a rules engine is triggered for action to be taken. These geofences can also act as corridors, so drones stay where they shouldn't and they don't exit where they shouldn't. And if they do trigger these edges. These rules engines, like I said, trigger lots of different events. You can cue a camera, you can write a police ticket, you can alert authorities. And one of our great claims to fame is the Fortem drone hunter. Maybe some of your viewers have seen videos, but we can cue a drone hunter. What a drone hunter is, it's another UAV about the size of a small coffee table, and it patrols an airspace, and it has a radar on the drone hunter itself. And that radar, when cued, will go to the volumetric exclusion zone and lock in on the rogue drone and pursue it. It'll chase it away, just like a radar-guided missile, but it's a radar-guided drone. It locks in like a dog on a leash. It just locks on the rogue drone. And if the drone doesn't leave, we can capture it with a net and tow the rogue drone away. It has lots of different modes, but that's the general idea.
It's all pretty interesting stuff. I want to backtrack and talk about the radar portion of it because, like you mentioned, it's a 70-year-old technology. And why did you focus only on radar, and what makes it stand out differently than the other systems today?
Radar is a great technology in that it sees day and night, and it sees everything. Its fundamental challenge has been that it doesn't see through buildings, and it typically has been very high powered. You had to have a special power plant to power these long range radars. Also, it emits, and so when you walk in front of it, these high powered radars can be dangerous with their emissions. The other problem with radar has been that because it does see everything, you get a lot of false positives. So a flag waving in the air will give you a trigger. And no security professional wants to be alerted at night when a flag's waving in the air. They want to be alerted when there's a drone entering a secured no-fly zone. So we looked at the technology, and we are able to overcome that technology in a number of ways. Number one is we made the radars very small, less than a pound, the size of your hand. And we're able to deploy lots of these throughout a campus or a city. And so even though a radar can't see through a building, you can put one small radar on one side of the building and another radar on the other side of the building. That's the first thing we did. The second thing we did is we put a high-end NVIDIA GPU into the radar. So anything that we see or detect with this radar day and night, 24/7, we're able to clean up the false positives with our artificial intelligence running on this GPU. We're also able to create filters to filter out things like the moving flag or the props on an air conditioning unit on top of a building. And so this GPU, this AI on the edge, if you will, this edge AI technology, along with a number of other leading chips that we put into the system, give us a really clean signature and classification of drone versus bird versus other things moving to really minimize the false positives. Also, because it's a small form factor, you can plug it into a standard wall socket. Also, because it has short and medium range, it emits like a Boy Scout campfire, so very safe to walk in front of, very safe for an urban environment. And then finally, the big disruption is all of our software. So we're able to, as a drone flies throughout a city and it crosses the path of 20 or 30 radar systems, we don't see this as 20 drones and 20 tracks across 20 radars. We see this as, one drone, one track across 20 radars. We associate all the tracks, and across the radar, we're able to create these volumetric exclusion zones that cross multiple radar systems. So you have massive redundancy. So no longer in a, like for the Department of Defense, do you have one radar that can be taken out and our warfighters are blind? And the same with our cities. Just as we have CCTV cameras for the ground, we can now digitize the airspace. And so law enforcement, our policymakers, our citizens can be aware of what drones are going where, which are safe, which are registered, which are staying in the corridors where they should to provide the services that we want, and those that are maybe acting in a more rogue manner.
When you say AI at the edge, what does that mean?
Yeah, some people call it AI at the edge or edge AI, is artificial intelligence. And so, a lot of historic systems sensors will capture data and bring it back to a central location. And then this mainframe computer will just be crunching on all the data, trying to make sense of it. Our approach is a little different, where we are pushing, in essence, that mainframe computer or all that calculation inside each of these tiny sensors. And so that NVIDIA GPU with 256 cores is crunching the data. And it's looking at everything in the airspace, a waving flag, propellers on an air conditioning unit, anything that moves, a bird, an airplane, a parachutist, even at LA airport, someone on a jetpack, manned jetpack flying. And it's looking at these images using radar. And that NVIDIA chip and artificial intelligence, these convolutional neural networks, the best way to think about it is we have, 100 scientists inside every sensor, looking at every image, making their best estimation. Is that a bird? Is that a drone? Is that a parachutist? Is that a flag? And every second, every day, 24/7, nonstop, that sensor is making those judgments and improving its capability. Every sensor at every location across the world where we're deployed. And as that learning happens, we push those data sets and that learning to all the other sensors. So it just gets better and better at discerning drones versus birds versus other things it sees in the airspace. And that's called artificial intelligence. It's driven by these new chipsets, and we're leveraging that at the edge in each of these sensors.
Can you talk about how effective the system is? Have there been any demonstrations or tests in the field?
Oh, absolutely. It's very effective. Very effective looking at the data that we're getting. We have data sets of over 180,000 now detects in the field. And our capability to determine if something's a drone or not a drone is in the high 80s, low 90% at this point. And it's just going to get better over the next few years.
Now that's the TrueView radar system. Let's talk about the SkyDome Manager.
SkyDome Manager is the software that aggregates all the data from all the TrueView sensors and gathers all that data into one holistic view across a venue, across a campus, or across an entire city.
Let's say, for example, someone has a stadium, a football stadium, a World Cup, something like that. How would you approach the engagement with that type of asset?
Typically a stadium, you'd have between 10 and 14 small sensors spread across the stadium. If the stadium is in an urban environment, you may have a few more other side of different buildings. And it would digitize the airspace, a mile or two around the venue. And with all of that data, you would know everything that's flying, and you configure your SkyDome Manager with different zones and different rules when it detected something flying where it shouldn't be.
And is that also a situation where the drone hunter could be housed if the client wants it?
Yeah, absolutely. And so the drone hunter, you can buy it with something called a drone hanger. It's a square box, looks like a nondescript air conditioning unit. It houses the drone hunter. It keeps it environmentally safe from rain and sleet and all those types of things. Also air conditioned from the heat. Also keeps it perpetually charged and ready to go. And so if you do run into a situation where the SkyDome Manager detects something in the sky where it shouldn't be, and you set up a rule to autonomously launch a drone hunter, the drone hunter would be there in its drone hangar on top of a building, launch, and deploy very quickly to the rogue drone. So the drone hunter would be cued by the SkyDome where to go, and it receives a continuous cue of where to go. It flies to where the puck is going, if you will. And it also, the radar on the drone hunter will lock in also and track the rogue drone.
I saw the videos of the drone hunter, and I thought it was just amazing how accurate it was and how it was able to get so close to another drone. Again, can you talk about its success rate over time?
Yeah, absolutely. So we started this in 2016, working with DARPA and other DoD partners. And it's been a long time, 2017, 18, testing every 6 to 8 weeks with our partners. Over the last year, since the middle of 2019, we've seen leaps in capture rate and capability. And so The drone hunter acts in two modes. One's an attack mode. So if the artificial intelligence in the drone hunter and the radar determine that a rogue drone is small and slow, we will chase it and we will attack it and we will capture it and tow it away. If the artificial intelligence determines that a drone is coming in very fast, like a fixed wing, and maybe is faster than the drone hunter or much larger, then we'll go into what we call defense mode. And the drone hunter will get in front of it autonomously, adjust its altitude, working, dive or climb with the incoming fixed wing or fast drone, and get in front of it and shoot it and capture with the net, kind of like a catcher in a baseball game catches a pitcher's throw. And so we have both the attack mode and defense mode that really increase the capture rate. There's also 2 shots on each drone hunter, 2 nets. So if you miss the first time, you're going to get it the second time. And so there's a lot of redundancy built in there with the dual nets and the different modes.
And all of that is done autonomously by the system as it's calculating the position of the rogue drone.
Yeah, I talk to customers and say you can set this up at night and come back in the morning and have a pile of captured rogue drones. However, most customers, the way they set it up with their rules engine is they have what we call a man on the loop, not in the loop, where they often want to have a human give permission to launch. And then the drone hunter defaults into pursue mode. And they often will configure the system for the human to approve a capture. But that's just configuration of the system and how you want to operate it as a user.
From your experience, what sort of time are we talking about from when your system first detects a drone and when action should be taken?
It's measured in seconds or minutes, not very long. And so it really becomes a question of the customer and the site. With our sensors, people often ask, what's your range? How far out can you see? And the answer is, it's infinite, scalable. Our design is you just add small sensors to look out as far as you wish to see. So we have a family of sensors. Our largest one looks out 1 mile. For a small drone, you'll see a Cessna at 2 or 3 miles. You basically need to, as a security professional, assess your risk and vulnerability for your site, try and determine what you think you're at most risk for, what the speed of an incoming drone might be that you're most concerned about. That'll dictate how many sensors and how far out you see in an urban environment around these buildings, etc. And then based on how far out you want to see, then you make decisions of how many drone hunters to deploy in these drone hangars. We had one customer around the stadium deploy 24 drone hangars. It's very analogous to a college football game. I'm from Ohio, and if Ohio State playing Michigan, you'd have hundreds of police officers with bulliers managing the ground security, right? And you would have, a few drone hunters at an event like that. Whereas maybe a high school game or a lesser game, you would have fewer police officers and fewer assets. But our premise is that, security has been on the ground for lots of years with fences and walls and metal detectors and bulliers. And our tagline is security elevated. So our customers now need to think about security above the fence line.
What type of assets would you consider to be the best customer for your system?
National security events, types of events like you listed them, like an Olympics or a World Cup or an inauguration, where the stakes are high, where people are solving for anti-terrorism. So if you're solving for a 12-year-old boy with a joystick taking a picture of Tom Brady, you're going to spend maybe $15,000 on an RF system, where you're just going to detect the RF communications between the boy's joystick and the drone, or the video downlink to the boy's video screen trying to get a picture of the football game. And so that's an inexpensive solution to what the industry calls a careless or clueless operator operating someplace where they shouldn't. However, if there's a terrorist or someone that wants to do criminal behaviors, like maybe fly over Warner Brothers studios, and there's nefarious intent, they're not using a joystick. What happens in those situations, Randy, is they're flying the drone with an iPad. And we call this a dark drone. What this means is that the drone that's flying was programmed to fly to point A, B, and C, take pictures, drop a bomb, do whatever it was supposed to do. And there is no joystick. The drone is flying based on a computer program. The drone is not emitting any RF signature. The drone is just listening to GPS or maybe flying based on optical terrain waypoints. So there's no emissions. So that drone will fly right over the RF antenna and not be heard or seen. There's nothing to jam on that drone. You can't point your jammer gun, to jam it to say, stop, go home, because it's not listening to any RF. You might as well point the jammer gun at your dog, tell your dog, to stop barking. It's just the physics of it don't work. And so the question was, what kind of customer buys Fortem? It's that customer that's trying to solve the 1%. 99% of the drones flying out there are just fine and benign. Just like 99% of the people walking by your store aren't going to rob you. It's that 1% that's going to break into your store and try and do something nefarious. It's that 1% of drones that has ill intent. And that's when you buy a Fortem system. That's when you want to detect everything in the sky and know where everything is at all time using physics. But you don't require the drone to be emitting anything. You're going to see it with our tiny radar sensors, and you're going to see everything that's there, and you're going to be able to stop it with a drone hunter, or at least be alerted of what the problem is to get the governor off the stage or whatever it might be that you're solving for in your security scenario.
The system as it's configured today, does it fit in with the current regulations, or do the regulations still inhibit your full deployment?
So that's a complicated answer. And the answer is on the radar and SkyDome, yes, absolutely. Radio waves have been broadcast in the United States for 100 years, right? AM, FM radio. You can go to the FCC for $50 and you can get a license to broadcast our radar. We broadcast across multiple airports legally in the United States and internationally, our radar. Just like when you go to the airport, you can listen to AM, FM radio. We're broadcasting at a different frequency with our radar. And so absolutely, radar, according to FBI, DOJ in the US and internationally, widely recognized as the way to go. As opposed to like RF systems that are listening in to communications, that breaks a lot of wiretapping rules and is illegal in the United States and many other countries, where radar is very legal, very safe, and it's all regulated by the FCC and other regulatory bodies across the world. With regards to the drone hunter is legal in many places in the world. In the United States, it's a little nuanced. For those that don't want to get too wonky, but in 1984, there was a law in the U.S. that said you can't shoot down airplanes. And that's a great law, right? I mean, you don't want our citizens taking shotguns and shooting down 747s because they're flying too close to their house and making too much noise. In 2002, Congress said drones are airplanes. And so in the United States, any lawyer will tell you, you can't use a drone hunter to shoot a net and remove a drone because of the 1984 and 2002 statutes. However, Fortem and other companies worked with Congress, and in 2018, they became legal to remove a drone with a drone hunter, but just for the federal government, DHS, DOJ, DOD, DEA, these types of federal agencies can now do it. And Congress is working with the federal agencies, DHS especially, to create the rules of engagement to create a pilot program for our state and local law enforcement to be able to do this.
Are the regulations such that the federal government could declare a certain asset as a national interest, say like a Super Bowl or a major event or something like that?
Yeah, so like I said, it's legal. Drone hunter is legal for the federal government to use the drone hunter to stop rogue drones. But New York Police Department, Chicago, LAPD, and the 18,000 other U.S. state and local police agencies currently don't have the authorities to remove a rogue drone, technically. However, we live in a country where common law prevails. Common law is right to self-defense, right to protect yourself from imminent threat or harm. And so, Randy, if there was a drone flying towards your head right now, I took my hand and swatted it down, no one would prosecute because, we would go to court and we'd say, yes, we damaged your personal property, Bobby, by knocking your drone out of the sky. But, common law, Tim Bean saved Randy's life. So we did it. And so just like with any weapon issued to law enforcement, using those weapons, there's rules of engagement and there's consequences for using those weapons when you don't follow the proper rules of engagement. And we've sadly learned that, especially over the last year. And so with the drone hunter, it's the same type of thing. What are the rules of engagement to remove private property from the sky? And our federal partners and our state and local partners are working through those rules, right now as we talk.
And to clarify, Tim, did you say that a pilot project was in the works for local and state law enforcement agencies?
The Department of Justice and DHS is working with Congress and asking the U.S. Congress to allow a pilot program to happen with some of the top state and local law enforcement agencies across the country. That act or that extension of the authorities has not happened yet, but there's a lot of lobbying going on within the halls of Congress to not just give this authority to the federal government, but also to some of our leading state and local police agencies.
As a city planner, I'm interested in the interaction of your system in the urban environment. So when you set your system up in the urban environment, what considerations do you need to account for?
The standard process of a city or an area within a city wants to manage their airspace and understand what's happening is we'll do a site survey. We'll look at the buildings and the topology and what's happening and try and understand, how much and how far out they want to see. And so we'll do a site survey to make sure there's power and Ethernet connectivity. We'll do the installation. And then we'll spend about a week tuning the installation. So, working with the, training the artificial intelligence of what to look for and what to ignore and all that. So you have a clean view of the airspace. And then depending on if the customer or city wants to have a drone hunter, we'll deploy those strategically based on, where their sensors are and what they're trying to protect.
You have a very diverse background in technology and in business. How do you describe your path into the drone industry and more particularly into the counter UAS sector?
So I grew up as a software engineer and building large communication platforms and found myself moving from engineering into the management ranks, general management and whatnot. After 9/11, it deeply affected me and started doing a lot of security work using large software systems, working with carriers across the world, signal intelligence to catch human terrorists, these suicide bombers through their communication links. Had a lot of success with that. And then when I came upon my business partner, Adam Robertson, who had developed this radar technology since 2011, working with our warfighters in Afghanistan and Iraq, we soon, after forming our company, saw that this technology would be used to find autonomous terrorist threats, where you no longer needed to recruit a suicide bomber. You now had an autonomous drone and soon an autonomous car to do the dastardly deeds that these people that are not our enemies think up. And so it's been a mission of mine to provide security. And I've never flown a drone, to be honest. I'm more of a security type person, technologist, somebody that cares about America, cares about our allies, loves freedom, and is driven by liberty for our warfighters, our citizens, our cities to have the freedom to have in our country. And so what we do at Fortem is not just about stopping terrorism, but it's providing a very large security layer across the urban landscape. We talk about our vision of digitizing the urban world, the urban airspace, to understand everything that's happening in the airspace and across our cities. is a tremendous capability that will enable what we're calling this $1.5 trillion urban air mobility market for air taxis and drones delivering your pizzas and all of these great services that we're all excited about over the next few decades.
Has the idea changed much since the technology was first conceptualized?
Well, yeah. I mean, as a business person, we've been doing this about 5 years, and we feel like we're making life and death decisions every month, Randy. But the big picture of using tiny radar to digitize the airspace, removing drones from places where they shouldn't be physically with other drones hasn't changed. I would say if I was to talk about decisions we're making now and changes we're making, you're going to see a family of drone hunters. You're going to see drone hunter technology that deals with swarms in the future, that deals with much larger threats, something that, scales as the terrorist threat continues to scale. We talk about the natural evolution of, our product and what it means to cities and to smart cities and understanding their airspace. With cities, we're working with them on specific corridors, point A to B, B to C, C to D, where they need enhanced services, where the ground traffic just is no longer tenable to provide the services their citizens need. So using drones to provide those life-saving services through our corridors is kind of our crawl, walk, run with some of these cities, building these corridors. But it's a very exciting future to be a part of and to drive and to use software and today's wonderful technology to make all of our lives more secure and more safe.
Is Fortem Technologies your first startup?
This is my fifth startup. This is the second one I personally started, but my fifth, startup, taking something from that's super small to super big. And so I love the challenge of growing something and being part of just a really big story and making an impact in the world. It's just very exciting to get up in the morning and do something like this.
What advice would you give to other entrepreneurs looking to start a company in the tech field?
I would say that don't follow your dreams, follow your opportunities and turn your opportunities into your dreams. That'd be one thing. The other is find out what your real passion is. For me, it's my wife and my kids and just the way I was raised in Cleveland, Ohio, and just the peace and security and the love I felt in my home. For me, it's the disruption of 9/11 and what that can mean to our country and to the people and the lives we want to lead and to kind of the fear that creates in our citizens and, what can I do about that? And so you tap into your sort of deep-seated id. I'm no psychologist, so I don't know if that's the right word, but I mean, the thing that really makes you tick. And then you find opportunities that you can feed that, and you turn those opportunities into your dreams. I've seen very few entrepreneurs that have just thought of an idea and kind of gone for it. More of it's a process of just working hard, having a solid reputation, and having a lot of professional contacts, and things start to come together, and you turn those opportunities into your dreams. And that's what we've done at Fortem.
And my final question, Tim, what message would you like to leave regarding the counter-UAS industry and Fortem Technologies?
We're just passionate about liberty, the freedom to fly, the liberty of our country, the peace that freedom-loving countries, Western world bring. Most of our business is international. There's a huge drone problem in the Middle East and Southeast Asia. And America, these things come home to roost sometimes. And so we're working hard with our international partners. And we just need to be ready as venues and campuses and cities to protect our airspace. And Fortem is dedicated to making sure that we all are.
That's it for episode 294 of the Drone Radio Show. I hope you enjoyed hearing from Timothy Bean of Fortem Technologies. I want to thank Tim for taking the time to speak with me. If you want to learn more about Fortem Technologies or want to connect with Tim, check out the webpage at fortemtech.com. If you like the Drone Radio Show, Please consider supporting the podcast with a small donation. The content is always free, but for as little as $1, you can help defray the cost of production. To donate, go to droneradioshow.com/donate. And thanks for listening. Your support means a lot to me, and I hope you'll listen to more episodes of the Drone Radio Show podcast to hear how others are using drones for business, fun, and research. For the Drone Radio Show, I'm Randy Goers.
This has been the Drone Radio Show podcast. More information on today's show can be found on our website at www.droneradioshow.com. If you're using drone technology for business, fun, or research and would like to share your experience on the show, please visit our website and fill out a guest appearance application. And don't forget to follow us on your favorite social media channels.